Hello friends, welcome to the day 19 session. We are going to discuss about linear regression. So before going to the linear regression, let me just quickly run for the yesterday's session. So yesterday we have been just seen about an Avis bias. What are the types of an Avis bias, that is Gaussian, and how to just make a simple prediction using a dummy data. So we have been just made a blob of a data. So this Gaussian Avis bias have been just successfully predicted the position of a new data, and it has been just given the respective colors like red and blue, and it has been just predicted and made into that respective classes. So the coloring is based on which class it is going to just belong with. So once we have been just seen with the equations and all, we have been just gone for one practical application is like text classification news group. So out of 20 text group, we have been just chosen 4 text cases. We have been trained a model. So first we have been converted into vectors, and we have been used multinomial Navier bias. So you can just give so you have been just trained it, you have been predicted, and you have been generated a confusion matrix. I guess you have been just seen what exactly the confusion matrix by the video you have been just shared with the yesterday's thing. So we have been just generated based on the sentences, we have been just written one simple function here. So it is going to take string, and it is going to predict in which model it is going to be present. So sending the first person to land on the moon, it is going to be resembling for space. So resolution for computer graphics. Diode is a forward pass, it is electronics. So which is the best motorcycle to buy within 1 lakh? It is a motorcycle one. So like this, for a user defined sentences or a string, it is going to just provide you which classes it is going to just work with, or to which class it can be just belongs to. So let's dive into the today's session. So here let me take a pen, and I am changing the color to black. So we are talking about linear regression. So the outline of this talk is to provide what is the introduction for linear regression, how it is going to be work better as compared to a Navier bias. So we are seeing some basic implementation using a linear regression. So algorithm working with mathematical model. So linear regression with binary classes, that is 2 decisions. So regression with multi-class. So multi-class means the decisions will be more than 1. And we are having one practical application, recognition of digits. So this is the outline of a talk here, of our today's talk. So let me just start with the introduction to the linear regression. So Navier bias is a starting point of a classification in machine learning. So by having some of our assumptions based on the bias theorem, that is probability of occurrence of features inside a labels. So this was a bias theorem, and it is a basic for a starting point for a classification. So linear regression, so this is for classification task. So like in linear regression, it has been just it is a starting point in a regression work. So regression work means the continuous values. So in regression also, linear regression also, we are having some of our classifiers and regression. But why actually this linear regression came into picture is, it is a starting point of regression works, like how to predict the price of a houses. So these kinds of applications can be just performed by linear regression. So why it is famous for? It is going to quickly finish the training part. So training is going to be finished accurately and quickly. So it is easily analyzable. So analyzable actually means that how exactly the output is going to be just performed. So it is easily analyzable how the accuracy of a system accuracy is going to be dependent. So like this, everything is easier compared to the other regression methods or classification methods. So easy to implement. Easy to implement actually means that, so linear means straight line. So straight line is going to be drawn between class 1 and class 2. So it is easier to implement. Why? Because a straight line is going to fit the two classes. So fit here means a training part. So here drawing straight line between the data set, linear data set, it is easier to implement. So here linear data set actually means that which are the data set which have been separable by linear lines. See, like if this was a circle and here if you are having a triangle, so here you are not having any overlap of a features like this. So if there is no overlapping, then it is going to call it as linearly separable data. So easy to implement actually means that fitting a straight line for a linear data. So packages installed or required, matplotlib, it has been already installed. So cborn, it is already installed, and numpy we have been already installed. So for a quick revision, how to install the packages is like pip install packages name. So you are going to just provide the package, pip install package. If you need to use it means same, import package name as any of our shortcut values, and you are going to use this shortcut for your programming part. I guess you will be knowing about this as you have been just familiarized with the respective Python coding. So let me just go to the simple linear regression. So straight line fitting a data. So the equation of a straight line you will be knowing, y is equal to mx plus c. So here m actually means that it is a slope of a line. So we'll be knowing about what is actually the slope of a line. Let me just explain it if you are just forgotten. So this is slope. So this is y is equal to mx plus c. So this is intercept. So this is intercept and this is input points or training points. Let me just have a respective graph here. See, consider you are having x-axis 0, 1, 2, 3, 4, 5. So this is x-axis. In the same manner you are having y-axis, and you need to fit a line. So this line is given by y is equal to mx plus c. So what is slope actually means that, so slope is having a formula. So change in y-axis value divided by change in x-axis. So what is the change in y-axis and x-axis? So this value is change in y-axis and this value is change in x-axis. So you are going to find a slope for this. So what does this intercept value actually means that? So what is the value of a, so I am talking about y-intercept. So what is the value of y when x is equal to 0? When x is equal to 0, what is the value of y? So that will be a y-intercept. So this is called both slope and intercept. So let me just give you how to have what is intercept for straight line. So here we have been just seen what is how to find a slope and what is actually an intercept for what is this y-axis. So let me just tell you the intercept for this straight line. So we need to find a intercept for this straight line. So I have been just told for a y-axis. So now your job is to just have a one straight line. You need to design a one straight line which is going to divide between two classes. So for this straight line, this is a equation mx plus c. So m means slope, you have been already find it out. So x means input values, we have been just providing. So we need to find intercept for the straight line. So how to find the intercept for the straight line? So let me take one of a simple example. So here this is x-axis and this is y-axis. Here I am taking a point for x-axis. At this point I am speaking. So this point I am speaking with 0 comma a comma 0. So now we can just find a respective intercept for a straight line. So first we are going to find slope of a line between 0 to a 0 comma b and a comma 0. So for this equation I am just writing. So we need to find a slope of a line. So change in value b minus 0. So change in y-axis I am taking first b minus 0. Next change in x-axis. So that is 0 minus a. So this slope is b minus b divided by a. So this is for whole straight line I am just telling. So let me take one of a point, a middle point or any of other point, and I am going to name it as x comma y. So any of the value. So x comma y. So now we are going to find a slope for these 2 points. So which is given by y minus 0 and x minus a. So this will be equal to y minus 0 divided by x minus a. So this is a slope for this point. So now we can equate this. So here we are having one part and this is an full part. So we are just having a equating value. So these two are always equal to, they will be equal to each other. So I am just equating it, y minus 0 whole divided by x minus a. This will be equal to the slope of a line. B divided by A. So this is, so here you are having a half line and this will be equal to the respective straight lines. So that's why I am just equating this both the slopes. So 0 to, so this one is for 0 comma B, 0 comma A, and here this is for from any point x comma y to A comma 0. So slope I am just taking. So I am just equating this part. So after equating, so here y minus 0 will be multiplied, cross multiplied by A. So that will be equal to minus bx plus ab. I am just cross multiplying the values here. So to this side and to that side. So a into y minus 0. So minus bx plus ab. So now you are going to just have a multiplication inside the brackets. So I am taking this plus bx to this side. Is equal to AB. So now I am dividing this AB to every part. AB plus BX divided by AB. This will be equal to 1. Sorry. So later I am just cancelling the common terms here. So this is a intercept to the line, intercept form of straight line, which is given by x divided by A plus y divided by B, that will be equal to 1. So that means just cancelling the respective form. So this is a intercept of straight lines. So this is a how to get an intercept for straight line. So how to generate a slope, how to generate an intercept of a straight line. So this is a mathematical model behind the intercept of straight lines. See, consider if you need to convert from line to intercept values. So line means it will be in the form of y is equal to mx plus c format. So I am just taking a one of example here. So that is 3x plus 2y is equal to 5. So now I need to convert this line to intercept. So what is the equation for intercept? X by a plus y by b is equal to 1. So we need to convert this equation to that format. So how to do this? You need to divide 3 by x, 2y by 5, which will be equal to 1. So now the right hand side has been just equated to the standard intercept of a straight line. Now you need to convert this x and y position. So x divided by 5 by 3 plus y divided by 5 by 2. So this will be equated to 1. So we have been just made equations to the standard intercept straight equation. So the intercept of A value is given by 5 by 3 and B value is given by 5 by 2. So this is like you have been converted the line to the intercept values. So these are A and B values. So B is your intercept and A point is your intercept values. So that is what y is equal to mx plus c. So in the form of constant. So that is b value. So these two are all the intercept value. Y is equal to mx plus b. So this is like you have been just given line and you need to find intercept. So if you are giving the intercept, if the person is giving the intercept and he asks you to convert into a line, then so x intercept is given with a value called 2. So y intercept is given with a value of 5. So now you need to convert this intercept values to the line, that is y is equal to mx plus b format. So first x divided by 2. So this is intercept for A and this is for intercept of B. So you need to make this in this format. So A value is 2, B value is 5. So now you need to cross multiply. So I am just taking a LCM here. So 5x plus 2y, which will be equal to 1. So now you need to convert this into straight line equation. 5x plus 2y, which will be equal to 10. So this is a line conversion. So if a question was like how to convert a line to intercept and intercept to line, this is a procedure you need to follow with. So if you are knowing the m value and intercept values B, you can draw the straight line. So the linear regression means you need to draw some straight line. To draw the straight lines, we need these two parameters: intercept form and slope equation. So slope is given by change in y-axis divided by change in x-axis. So the intercept values you are going to just find it out based on the straight lines. So based on this, we are going to just code the linear regression. So let us see some of our sample code here. So we have been understood what actually the straight line equation, which is going to just give with y is equal to mx plus intercept format. Y is equal to mxc or b, anything. So this is intercept and this is slope. So first we are going to generate some of our, so we have been just seeing what are the parameters, coefficients and intercept. So this is intercept and these are all the coefficient values. So we can just jump into the sample program. So like using the packages, and we are going to see how exactly this linear regression is going to just work with. So new scratch file, Python. We can change this name. Where is this? Okay, day 19. So in this, first we are going to import the packages matplotlib.pyplot as plt, then import numpy as np. Then what is another thing? I guess only this much. Let me see here. Packages required. Okay, cbor. Whenever it is necessary, we can just call it. Okay. So after this, we are taking a range of values. So this is a sample code. So we are just generating a numbers. So random state. So random state. So this is what we have been just seen while seeing through the what is this scikit-learn. So the examples. So now we will be convenient. So x equation is some set of input. So we are generating some set of input here. So random of 50. So y x value we have been got. So y is equal to mx plus c format. So here I am making the slope as 2 and intercept value as -5. So that is what the equation is going to tell you. M is 2 into x value we have been already generated input values. So this is a what is this intercept values for all the random values. So we need too many random integers. So that's why we are using this format. So the equation is same. Y is equal to mx plus c. So if we are knowing slope and intercepts, we are going to write a linear regression. So now we have been generating a points here. Later we are going to see how to make a linear regression. So this is data creation. So we can just plot this. Plot dot scatter. So scatter, what you are doing, you are just pushing x comma y. So you are going to plot this. So soon after plotting, you need to just write plot dot show, or else it will be not holded off till the respective user is going to see it. So plot dot show. So next we can just see the output here. So these are all the data points which have been scattered all around. So we are having x values, and this is a straight line we have been generated with a different slopes or different values of input. So input value will be go on changing here as it is random state. For that, slope is multiplied and intercept value is subtracted. So for these values, what we are doing is we are going to use a scikit. So scikit-learn. So we can just write here from sklearn dot linear model. You are importing linear regression. So you have been imported this linear regression. So now you need to have one model as per the discussion. Once data has been just generated, you need to choose a respective features and later model and classification and evaluation. So as per the machine learning, so selection of a features has been just provided to the machine. So we are just choosing which method, and we are seeing well whether it is going to operate or not. So fit intercept, so it is a truer one. So we are going to fit the intercept values. So after this I am going for training version model.fit. So I am taking only the columns. So np dot new axis. So new axis means it is going to create in new column. So x will be in column fashion, so that is one below the other, and y will be also with the labels. So now we have been preparing a table format of x and y. So x will be in column format, that is row by row you will be having features and you will be having points. For those points, y will be also having another scattered straight line. So you are going to fit this straight line, y is straight line, and you are going to fit this straight line to the linear data. So then parameters are coefficient and intercept. So here I guess this new axis means so slicing a row and it will be converted into a single column. So if you are having numerous rows, it will be converted to a single column to make it to look it as a table. So all the data will be in the form of tables. So let me just print the coefficient values here. So print the model coefficients. So print. So what is model slope? So the model slope have been just available in model dot coefficient value of 0. So model coefficient, that is slope, y is equal to m value will be at a starting position. So next you can just copy this and you can just paste here. So now you are going to see the model intercept value. So that have been available in model dot intercept underscore. So this is like you have been fitted a value. So now you are going to just see how exactly the model have been fitted and what are all the coefficient values for it. So this is a respective straight line. So model slope is 2.02. So we have been just provided 2, that is almost equal to 2. So 4.99999. So that is our intercept values what we have been just given with. So these are all the model coefficients and this is like parametric analysis. So the classification is based on the parameter. So this linear regression is also a parameter wise. So naive Bayes also. SVM is also parametric analysis. We are going to change the parameter value. So the accuracy will be go on changing. So we can just see that SVM working in the next class. So here model dot intercept, model dot coefficient values we have been just seen with. So this is like we are having only a single value of x. So if we are having multiple values of x, so instead of only single column, if we are having multiple values of x, then the equation is going to be just changed. Okay, let me take a pen, change the color to black. So now I am just talking about if the value of a x is multiple. So a0, so a1 x1 plus a2 x2 and so on. So if you are having more than one value of x, so this is a equation for having multiple dimensions of a input. So multiple inputs of a x value, this is a equation. So for as per this equation, again we are going to just have a sample modeling. So like sample coding as well. So we can just see it in a pie chart. So here we are having the x as, so we can take it as x1. So x10 into RNG, the same value, range value. So we are having a multi-dimensional data here. Instead of a single, we are having multiple datas. So y equation is slope is 0.5. So here you are going to have a dot operator. So to perform each dot operation, so x1 comma 1.5 comma 2 minus 2 comma 1. So for these many values 1.5 minus 2 and 1, so you are going to just generate a random values of x. So for this you are going to plot. So you are going to make a model dot fit for x1 comma y, and again you are going to see the fitting equation. So this is for multi input of x. So you can just see how the slope is going to be just varied. So you can just see the slope is 1.4449 and intercept value is 0.5. So like this you can just see that if the multiple values of x is going to be present, you can just you are going to generate a straight line for this. So you can just see the plot as well, like plot dot scatter with x1 comma y, and you need to wait till the user is going to delete or close the figure. It happened. So after having fit, so I need to have xfit value np dot line space. So you are going to have 0, 10 to 1000. So yfit will be having yfit will be model dot predict. What we are going to predict is xfit value, and it should be only in columns np dot new axis. So now I am plotting scatter of x comma y, and I am just plotting x fit comma y fitted value, and I am just giving a title for this as predicted linear data using linear regression. So after this I need to wait for plot dot show. So this is for how to judge a linear model. So now we can just see the output here. Okay, let me see this later. Can just execute this plotting of predicted value of linear data. So you can just see predicted value of linear data. So this is a straight line which are being just generated to make a difference of these two points of different classes. So this is linearly separable data. So some of the points have been overlapped. So that is of lesser, like 1% of data, you can just ignore it. So this is prediction of linear data using linear regression. So that's how we are being just generated a straight line for linearly separable data. So if you are having data like this, if the data is linearly separable, then you can generate a straight line. See, like if you are having non-linear data, so this is for linear data. So the next one is for non-linear data. See, like the non-linear data actually means that, see, consider if this is a space of a respective machine learning experiment, so the data will be in this format. So this is non-linear data. So if you are using linear one, it will be not providing a effective results. So the non-linear actually means that, so non-linear actually means that So the line should be not straight. So like this. So it can be curve as well. So this is called as an polynomial. What is this? Linear regression. So you are having multiple values of linear regressions. So the equations for the multiple values of linear regression is y is equal to a0 plus a1 into x1 plus a2 into x2 plus a3 into x3 and so on. So this x is the input and y is a is a intercept values. So this is going to call it as a multi-dimensional linear model. So this is going to call it as multi-dimensional linear model. So x of 1 n will be the function of n of x. So here function actually means that, so it will be of having some equations. So the x will be, I have been just provided in the code which have been provided by some value into random value that have been just provided. So this equation is going to call it as function here. So what is this x is going to do is, so based on this function, so if we are providing a different value of x, you will be getting a different values for different x value. So x1 can be anything, x2 can be different, so x3 can be different, like this. So x1, x2, x3. So let us just see the polynomial equation. So this is a linear model equation. So let us see how exactly the polynomial model is going to just see with. So it will be one and the same. So this is a polynomial, what is this, regression equation, and this is a multi-dimensional linear model equation. So here now, so we are going to predict the non-linear data. So these are the equations. So before going for a prediction, we need to discuss about polynomial features. So what this polynomial features actually do is, so this is going to just, features is going to convert a 1D to 3D arrays. So what actually it means that if we are giving one dimensional array like 2, 4, 3, it will be generating a, that is a square of that respective, cube of that respective values. So it is going to convert into 3D format. So like multi-dimensional data. So this is called as an polynomial features. So it is going to convert from 1D to 3D array. So let us see this, how exactly it is going to just work with. So that will be clear, that will give you a clear picture of what is the working of polynomial features. In order to use this polynomial features, you need to go for from sklearn.preprocessing. What you are going to do is you need to import polynomial features. So pre-processing, you are going to import the polynomial features. Now I am just taking a, what is this, one dimensional array. So 2, 3, 4 as I have been explained. So now I am just going for poly and I am using polynomial features we are going to convert into include bias is equal to false. So what does this include bias actually means? That so whenever we are going to design any of our machine learning things, so the initial conditions will be provided. Those initial conditions is not needed for linear regression. It is being needed for what is this artificial, that is neural networks. So here we are going to convert it into an 3 dimensions. So now we can just have this print of this poly. We can just see how actually the respective values are going to be just changed after pushing a 1D array for a using a polynomial features. So that degree will be changed to 3. So the degree will be changing from 1 dimensional to what is this 3D dimensions. So you can use this poly to fit. So you are going to have fit transformation. What you are fitting? x2. So x2 of you are interested with only columns. So this is like how the single dimensional 1D data have been converted into a 3D values, that is 3D array. So this 1D have been converted into 3D arrays. So this have been used in non-linear regression. So this is like for this non-linear regression we are going to use a pipeline. One after the other we are going to use the pipeline and we are going to make a linear what is this prediction. So for non-linear data we have been just seen this polynomial features. So for this polynomial features, okay. So we are having different bias functions. First one is polynomial function and next one is Gaussian bias function. So let me take another blank sheet to explain what exactly we have been needed here. So now we are going to go for non-linear data. So we can just see how the model fitting is going to happen whenever we are going to have with a non-linear data version. So non-linear means the data is not separated by the straight lines. So we will be having some sample code here. So we can just go for this by the usage of polynomial respective form. So let me take a x5. So 10 into RNG dot random of 50. So y will be equal to np dot sine of x plus 0.1 into RNG dot RAND n of 50. So this is x and y we have been just generated. So for y also we can give it as 5. So what we are doing is we have been just using polynomial fit model, polynomial dot model dot fit. Okay, we have been not defined this polynomial model. Okay, I was been talking about this pipeline. For this pipeline, you need to just do this scikit-learn pipeline, and you are importing make pipeline. For this make pipeline, you need this poly dot underscore model, and you are making a pipeline of 3D data, and you are pushing polynomial features of 7, and you are calling linear regression over here. Copied and pasted in order to save the time. So here polynomial features of 7, and I am just taking how to predict the respective multi-dimensional data. So we just need only these values. Okay, so we just typed it earlier, so we can just go for x5, and you are going to print both this. So the x fit is given by the line space. So this is a like a numpy array. We are just creating some of our dummy values, so starting from 0 to 1000. So this is called x fit. So these are all the line space value we are going to just predict it with. So x fit comma y fit, and we need to go for plot dot show, plt dot show, plt dot show. So now we have been scattered the data here, x comma y. So x5 comma y5 we have been scattered. For the scattered data, we are just seeing how the fitting value is going to happen if we are having non-linear data. So this is for linear one, which have been seen earlier. So it is lines space, numpy. So it is line space. So next we are going for non-linear data. So that is what we are going to just do here. So we can just start with a newer value, or we can just go with new values of x and y. So x1 is having 10 plus 10 into range of random 100 comma 3. So y is equal to np dot x1, so these many values. So we are going to fit it. So we are going to see some of our, what is this, multi-model slope values, and later we are going for some of our polynomial equations here. So let me take the newer values, like x10 is equal to np array 1 2 3. It has been converted into these many values, and you have been included the bias. So you are going to just make a poly dot fit transmission of x10. So then we are going to have a poly model pipeline. So once the pipeline is done, we can just write a new range values. So np dot random state with 1. So y equals np dot sine of x plus 0.1 into RNG dot random n values to sum of a 30. Okay, we can just give it for 50 random values. So now we are just making a poly model. Can just delete here. So here poly model have been just poly model dot fit for a x10 value, x10 of, so we're accessing only the columns dot new axis comma y, and you are closing this one. Okay, we are fitting it, and we are having y fit will be equal to poly model dot predict. So what you are predicting? X fit. So the two of with only a row value, new axis, you are just predicting, and y fit will be equal to poly model dot predict x fit comma np dot new axis. So now you are going to plot scatter x10 comma y. Then you can plot x fit comma y fit. So you can just change this to y1 also. Just for confusing sake, I am just changing this. Now you need to just provide a title saying that, so it is non-linear prediction of data using linear regression, or that is using polynomial regression. Okay, now you are going to plot dot show. Then you can just run this. So this is our data, linearly separable data. We have been separated this linearly separable data using straight line, using linear regression. So next, where it come? So next we are going to see nonlinear prediction data using okay, we're having some error. Let me just type all those things in a new page. So this is like non-lineable data.